Hey, back again. I'm going to complete this part B of the Cornell notes of factor by GCF. So just going to go through a couple examples that will hopefully help support you as you go through these practice problems. So first I just want to talk about is factoring completely and making sure that it is completely factored. So when we look at this one right here where we have 12a squared plus 16a, you can see over here that this person saw they both were even and took out a 2. They took out an A because A2, and then we have this 1, and so A1 is the smallest, so that's what they took out. If you have 2 A's, take out 1, you're left with 1. If you take the only A, you have no A's, and then they wrote it out. Over here, my orange person right here, they took out a 4. So 12 divided by 3 is 4. 16 divided by, 12 divided by 4 is 3, and 16 divided by 4 is 4. And then they did the same thing with the A's. This one is actually incorrect, and this one would be correct. The reason why this one is not right is because if you look here, we have a 6 and an 8, and there's still a 2 that we can take out of both of those. So if I was this person, I could take out another 2 here. So if I would have put a 2 here, then I would have been left with a 3 and a 4. And I still have my A's there. And then I can take out my A's. All right, so just be careful of that. Just make sure that when you're doing these that you are completely factoring it. I'm actually going to go ahead and finish filling this out just so that y'all don't get confused. So now when I take that A out, I'm left with 3A plus 4. And so when I take this little GCF piece here, then I have my 4A and my 3A plus 4. So don't think you can't break it down. You can still break it down. You just have to make sure that you completely factor, all right? So just be careful of that. So now this would be correct as well. So looking at this example here, and we're going to call this example 1. I'm going to go ahead and set up my upside down division. And I'm going to always start with my numbers. So when I look at 5 and 35, what number will go into both of those? All right, I hear you. You are correct. It is 5. So now we're going to divide each of these. So 5 divided by 5 is going to give us 1. So we have 1x. And then 35 divided by 5 is 7. Remember, whatever the symbol is, we're going to keep it the same. If you notice, there's an X here, but there's no X there. So therefore, we are done. This right here is our GCF. So I'm going to put my 5, and then I'm going to bring down my leftover, X minus 7. And that's how you do that one. When we look at example number 2, for this one, same type of deal. To take this, write my little upside down division. So we have 3x squared minus 27x. I'm going to look at my numbers first. I have 3 and 27. What number will go into each of those? You are correct, 3. So 3 divided by 3 is 1. So I'm left with x squared. 27 divided by 3 is 9. Good job, y'all. Y'all are on it. We also know that we're going to keep our symbol right here the same. But this time, if you notice, both my terms have an x term in it. So when we're looking at the x term, we have an x squared and we have an x1. Which one's smaller? X1. So I'm going to pull out an X. Remember, we always pull out our smallest. So if I have 2 X's here and I take 1 X away, how many do I have left? 1. That is correct. I'm going to keep my minus and my 9. And if I have an X, if I only have 1, I take that only 1 away. How many do I have left? None. So again, this outside piece right here, that will be our GCF. So I have my 3x. And then this last little rung right here would be my leftover. And then this would be how I write my final answer. All right, we're rolling now. Let's go and get to number 3. So when we look at number 3, we have negative 10x plus 60. So I'm going to go ahead and set up my upside down division, aka my ladder, aka UDD. I'm going to go ahead and put that around there. And I'm going to look at my numbers, right? So we have a negative 10, but we also have a 60. So what number we're going to 10 and 60? 10. Good job. Do not let the negatives bother you. Do not worry about taking out no negatives. We'll talk about negatives in the future. So this negative is going to stay there. 10 divided by 10 is 1. So we end up with a negative x squared. I have my plus here. 60 divided by 10 is 6x. If you notice, I try and keep everything lined up. Like every single example, my minuses line up, my terms line up, just to help me maintain the flow and the consistency of my work. When I go on to the next rung, if you notice, I have x squared and x, so they both have x's. So I have an x squared and x, an imaginary 1. Which one's smaller? You're correct, just a single x, so x to the first. If I have 2 of them and I take 1 away, I am left with 1. So I have my negative x. I'm going to add that. If I only have 1 x and I take it away, you have no x's left. So again, on the outside here is our GCF. And so we have 10x. And then we have our leftover. So negative x plus 6 is our leftover. Give me a little check. On fire. All right, so we got 2 more left. So when we look at this one, we have 12x plus 32x to the 4th. And so when we look at this, you might not see that 4 can come out from the get-go. So let's break it down a couple of times. Hopefully you realize both of them are even. So I'm going to take out a 2. 12 divided by 2 is 6. Keep my plus. 32 divided by 2 is going to give me, 16? If you look at them again, they both are both are even. So I can take out another 2. 6 divided by 2 is 3. And 16 divided by 2 will give me 8. And so when I look at this row now, nothing will go into 3 and 8, so I'm done. And I can look at my variables. So my first variable that I notice is that I have x. So I have x to the 4 and x to the first. So which one's smaller? Just my single x. So I'm going to rewrite my 3. If I take out this only x, if I take it out, I have no x's left. When I go over to here, I have x to the 4, which means I have 4 x's being multiplied. If I take away one of them, I only have 3 left. And so that is it. Right here, I multiply out my GCF. So 2 times 2 is 4, times 4 is 4x. And then we're going to put our leftover inside our parentheses. All right, and our very last one that we'll work through, it looks like we're given 45x to the third power plus 5x. So I'm going to go ahead and set that up. While I'm setting this up, when we look at 45 and 5, what number we're going to both of those? You said 5, you are right. So we're left with 9x to the third plus x. I got x3 and x1, right? So x3 and x1. Which one's smaller? The x. So now I have 9 If I have 3x and I take 1 away, I'm left with x2. And if I have an x and I take the only x away, what am I left with? No x's. But we have to have a place value, all right? Because if you think about it, if I do x1 divided by x, imaginary 1, remember when we divide, we subtract exponents, right? So 1 minus 1 is 0, and anything to the 0 power is 1. So that's why I put a large 1 there, all right? So really be careful that a lot of students miss that key fact. Our GCF is on the outside, so we have 5x, and then our leftover goes on the inside. Cool. So I really hope these videos help. Again, if you have any questions, concern, please just email your teacher and they can definitely give you more assistance with this.